Hello everyone, welcome to lesson 9-3, two-way tables. In this lesson, we will continue to address how patterns are used when comparing two quantities, and we will use the vocabulary relative frequency and two-way table. Let's take a look at how to apply today's lesson in a real-world scenario. Let's talk about student athletes. The data from a survey of 440 students are shown in the table. The students were asked whether or not they were on the honor roll and whether or not they played a sport. So here we have the survey results, where only on the honor roll we have 115 students, only play a sport 45 students, and the number of students that were on the honor roll and play sports were 250 students. So played a sport and are on the honor roll, 250 students. Let's complete the Venn diagram to represent the data. So we have on the honor roll, only on the honor roll, we have 115 students. And the ones that only played sports were 45 students. Okay? And in the middle, the ones that both played sports and were on the honor roll were 250 students. Okay? So now let's take a look at what relative frequency means. Okay, relative frequency is the ratio of the value of a subtotal to the value of the total. So we're going to find a subtotal, and that subtotal will be compared to the total. We're going to write a ratio. A ratio is a comparison of two numbers. And here they are. This is what they are asking us to do. What is the relative frequency of a student that is on the honor roll, so students that are on the honor roll, and play sports, okay, so the middle one. So students that are on the honor roll and play sports, so 250 students, to all students that are on the honor roll. So we have here students that are honor roll and honor roll here as well. So combined between the 250 that play sports as well as being on the honor roll to the ones that are only on the honor roll, combined we have 365. So we're going to compare that 365 to the number that are both on the honor roll and play sport, as you see that, honor roll and play sport. So that would only be the 250. Okay, 250. And that compares to, if I were to simplify it and take the top number or divide it by the bottom number, that's going to be about 68%. And now we're going to use that ratio to answer the next question. Is there evidence that students that play sports are also on the honor roll? Well, sure, there are, because like we said, that's about 68%, which indicates that more than half of all the students on the honor roll also play sports, more than half of them. So what do we write? We would write that yes, there is evidence, because 68% indicates that more than half of all students on the honor roll play sports. And that leads us into our key point, one of our key points for the day. We're going to talk about two-way tables. So constructing a two-way table. What is it? A two-way table shows data from one sample group as it relates to two different categories. The same information from the Venn diagram on the previous page is shown below as a two-way table, where one category is represented by rows and the other category is represented by columns. The two categories in the table shown are play a sport and on the honor roll. So we have here on the honor roll, which is the sum of the students that play sports and don't play sports but are still on the honor roll, is 250. And the ones that do not play sport out of that group, okay, is 115. And together they have 365. Not on the honor roll, we have only the 45 students that just play sports. And the students that do not play a sport, okay, is only 30. which together makes 75. Now you're probably wondering, where did that 30 come from? Well, keep in mind that in the beginning we did say that there were 440 students, right? 440 students where 150 are on the honor roll plus 250 are on the honor roll and play sports, and only 45 are not on the honor roll but play a sport. That only gives us 410. 150 plus 250 plus 45 is 410. So there's another 30 that are neither. They do not play a sport and they're not on the honor roll. Okay, so that's the one that we're accounting there for. So here we have a total of the students that play a sport. Okay, the students that play a sport are the 250 that are also on the honor roll, plus just the 45 that are not on the honor roll. Together they make 295. The ones that do not play a sport, the 150 that are on the honor roll, and the 30 that are on neither the honor roll nor play a sport. And together they make 145. And you see that together they make the 440 that we originally started off with. Okay? Okay, so now let's break it down step by step on how we would do this ourselves. Let's look at the example with Felipe. Felipe surveyed students at his school. He found that 78 students own a cell phone and 57 of those students own an MP3 player, or what we can say an iPod. There are 13 students that do not own a cell phone but own an MP3 player, 9 students that do not own either device. Construct a two-way table summarizing the data. So we need one for the ones that own a cell phone, the ones that own an MP3 players, and the one that own neither, right? Or actually, no, cell phones, MP3 players, okay, very good. And no cell phones, no MP3 players. So here we have the two-way graph. We have people that own MP3 players and no MP3 players, and on here we have people that own cell phone and no cell phones. And we are told that 78 students own a cell phone. So 78 students own a cell phone, and 57 of those students own an MP3. So MP3 players and cell phone players are 57. Okay, 57 students own both, right? But there's a total of 78 students. There's a total of 78 students because 78 of them own only cell phones. No cell phones, we have 13 students. There are 13 students that do not own a cell phone but do have an MP3 player. So they fall under the MP3 player, but they have no cell phone. And 9 students do not own either one. Okay, and that's how we would fill it out. Once we organize our data, we jump down to step 2. And in step 2, okay, we start to fill in with rationality. Use reason to complete the table. Remember, the totals are for each row and column. The column labeled total should have the same sum as the row labeled total. Okay, so columns go down and rows go across. So if I have 78 students, right, that have cell phones, and 57 of them have MP3 players and cell phone, how many of those with cell phones do not have MP3 players? Well, you find the difference between the two. Okay? When you find the difference between the two, you get the ones that have a cell phone but no MP3 player, which is 21. Then you already know of the 13 that have no cell phone but have MP3 players and have no cell phone nor MP3 players, and together they make 22. And then finally, going down, you see here that we have MP3 players, 70, no MP3 players, 30. Okay? And together they make over here 100. And that is a two-way table. Now let's try it. Please take a minute to copy down a table similar to this one, okay, where you have your columns for canoes, no canoes, or canoeing, no canoeing, and your totals, swimming, no swimming, and your totals across the bottom, where we have two tables, one with columns and the other one with rows. Okay, please pause if you need to pause. If you're ready, let's take a look at this together. There are 150 children at summer camp and 71 signed up for swimming. Okay, so we have swimming right here, and we're going to take them into account in a minute. There were a total of 62 children that signed up for canoeing, and 28 of them also signed up for swimming. Construct a two-way table summarizing the data. So, okay, wait a second. Here we have 71 signed up for swimming. Okay, now I'm just going to write for swimming here. I know that I have 71 of them in total, and that's my total because they're telling me, but then they break it down in how they break up in here. They're telling us that there were, out of those 71, there were a total of 62 children, okay? There were a total of 62 children that signed up for canoeing. So a total of 62 signed up for canoeing. So I have to put that total down here, if that makes sense to you, right? Total of canoeing were 62. And 71 signed up for swimming, which is another total, 71 for swimming there. So far, they've only given me the totals, right? And then they say that there were a total of 62 children that signed up for canoeing, and 28 of them also signed up for swimming. Okay, canoeing and swimming is 28, as you can see, right? So now we have to figure out the other numbers. We have to construct. So here we have to find the difference. Of the ones that swimming, 71 of them were swimming, how many did not sign up for canoeing? We have to find the difference between 71 and 28, right? So you take your 71 and you subtract 28. And I get 43. So 43 of them signed up for swimming but not canoeing. Then we continue on and we understand when we move down the column this way, because we have another total here of 62, we understand that 28 of them signed up for canoeing and swimming. What about the ones that signed up for canoeing but not swimming? We find the difference between 28 and 62 to fill in that gap, and 28 plus a number is 62, or 62 minus 28 is equal to 34. Okay? Now, I do have one more number that was given to me, and that is the total number of students. There are 115 children at summer camp, 150. So altogether, right here at the corner where the total goes, and I say total because I mean this total and this total, is 150. Well, again, how do I get to that 150 from here to here? I have to find the difference. 150 minus 71 is 79. Okay? And in the other direction, 150 minus 62, okay, is equal to 88. There we go. And then working my way down with no canoeing and no swimming, we have 45 students. So you can see that we can solve for all the missing variable as long as we're given some key numbers. For example, like the totals of 62 and 71 was very important. The total between 71 and 62, okay, gave me 133. So it didn't give me complete all of the students or all the campers. It didn't give me everybody. So this value was also necessary to be given. And then they gave me the 28 that were canoeing. And with that information, we were able to solve the rest. So as you can see, it's really important to be able to interpret data and infer and fill in the missing numbers that are often not given, but we are able to find. So interpret relative frequencies. A two-way table can show relative frequencies for rows or for columns, rather than the actual values. By analyzing the relative frequencies in a two-way table, you can determine possible associations between the two variables, essentially determining percentages, likelihood, and whatnot. So let's practice that here in example 2. Find and interpret the relative frequencies of students in the survey from example 1 by row. For example, we fill these out, right? And we have the cell phones, the no cell phones, the totals, the MP3 players, no MP3 players, and the total. To find the relative frequencies by row, write the ratios of each value to the total in the row, round to the nearest hundred. So for example, we have here 57 students with MP3 players out of the 78. Okay? And we have 21 here out of the 78. So when we write it like that, 57 students, 57 out of 78, it gives us about 73%. We can turn this into percentage. And over here with no MP3 player, we have about 27%. Okay? 78 being our whole, our total. And so on. So no cell phone, you can do the same. 13 out of 22 and 9 out of 22. Okay? And you get your percentages, 59% and about 41%. Only the totals needed are shown in the table. Based on the relative frequency value of 0.73 in one of the cell phones, you can imply that most students that own a cell phone also own an MP3 player. The data also suggests that over half of the students that do not own a cell phone will own an MP3 player. And that's how we reach these inferences. Okay, and let's try our last example. Please, again, copy down this table. You can pause the video now and then fill in the table as we go. Pause now. Okay, I hope you paused the video. Let's read. Find and interpret the relative frequencies of students in the survey by column. Round to the nearest hundredth if necessary. So we were talking about the students earlier with cell phone and no cell phones and MP3 players and no MP3 players, and these are the numbers that we came up with: 57, 21, 13, 9, 70, and 30. Now remember that we have to find the total number of students that we were talking about. Total number of students with MP3 players was 70, as you can see here, it's being given. And the total number of students with no MP3 player, okay, it was 30. So we have to find the relative frequencies. And for that, we have to write in 57 here out of 70, right? And over here, we have 13 out of 70. And that gives us here approximately 81 or 81%. Okay, and over here we give about 19%. And then for the no MP3 players, but with cell phones, we have 21 out of the 30. And with no MP3 player and no cell phone, we have 9 out of 30. And in percentages, that's approximately 70%. I should write it as a decimal. 0.7 and 0.0, approximately again, 0.3. Right? So what does that mean? It means that the relative frequency value of 0.81 or almost an 81%, but this being almost a whole in one of the cells, in this cell right here, strongly suggests that students that own an MP3 player also own a cell phone. The likelihood is high. Okay, so that is what we see, that there's a strong suggestion that students that own one own the other as well. And you can see that it's not the same for cell phone, it's lower and whatnot. And this is how we come up with relative frequency. Okay, everyone, we'll continue in class with the guided practice. See you then.